Hello, in this video I will go over the fundamental theorem of calculus part 1, and yes, there's also a part 2 of fundamental theorem of calculus. And then I will also review some integration rules and properties. There's two fundamental theorem of calculus, FTC number 1 and FTC number 2. So let's briefly review some integration rules. So the integration of 0 is just 0x plus c or just c. The integration of k dx, so the k you can take out if you want, because that is a constant, and then you have 1 dx, and then it's just going to be, you're going to add a letter, and whatever, it's the letter that you're taking the integration in respect of. Since it's dx, we're going to put in x, and then bring down your constant, and then plus c. And then the integration of k of the integration of k f of x d of x is integration of k f of x d of x, which is k f of x plus c. Okay. Uh, Rule 4, integration of f of x plus or minus g of x of d of x. Basically, you could just take the integration and make it into two parts or three parts. Number 5, the integration of a to b of f of x of d of x. And we're going from a to b. So if it's a really long integration, you could break it into two separate integration. You can go from a to c to d. So these has to be the same. And yeah, I'll explain when we do an example. In rule 6, the integration from a to a of f of x d of x is equal to 0 because you're not going anywhere, right? So the area has to be 0. Uh, Rule 7, the integration of a to b of f of x equals, and then if you switch the boundaries from upper to lower to upper, it's going to be the same answer as this, but the only difference is you put a minus in front. That's it. Okay. Number 1 says evaluate. Uh, if integration from 0 to 10 of f of x d of x equals 17, and the integration from 3 to 10 of f of x d of x equals 6, and the integration from 0 to 3 of f of x dx. So we have to go from 0 to 10, right? So they don't give us an equation, that's fine. But like maybe if we kind of like drew it, the boundaries on a number line. So our smallest boundary is 0 and our upper boundary is 10. And we have to find the entire integration from 0 to 10, right? That's what we want to find. But they're saying that the integration from 3 to 10 is 6. Let's say here's 3. So this entire length is 6. And what else do they say? The integration, we got to go find, oh, and then the integration from 0 to 10, so this entire length here is 17. So all we got to do is find they just want to find the integration from 0 to 3, so this length here, right? So what we could do is set it up as an equation. Let's say that from the integration of 0 to 3, we'll set it up as the integration from 0 to 3 of f of x d of x plus the integration from 3 to 10, which we know is 6, equals the entire integration from 0 to 10. Okay, so do we know the integration from 0 to 3? No, we don't. Let's just call it as it is. I don't know what it is, so just leave it as it is. Do we know the integration from 3 to 10? Yes, it is 6. And then do we know the integration from 0 to 10 of f of x d of x? Yes, it is 17. And then all we got to do is to solve from the integration from 0 to 3. All we got to do is subtract 6 from both sides. That gives you integration from 0 to 3 of f of x d of x equals to 17 minus 6 is 11. So this is your final answer. Okay, so that's how I would do that one. Let's look at examples 2. If the integration from 0 to 6 of f of x d of x equals 4, and the integration from 6 to 2 of f of x d of x equals 1, find the integration from 0 to 2 of 3 f of x d of x. Okay, so let's kind of draw it on a number line. So our smallest boundary is from 0, and our most upper boundary is 6. It doesn't go any higher than 6. We could go from and then they're saying that we want to go from 0, we want to find the distance from 0 to 2. So let's say this is 0 to 2. I don't know what that is, but I do know that the distance from 2 to 6 is 1. So this entire length here is 1, right? And what else? Oh, what else? We see here we're going from a upper to a lower. So if you go back to your rules, rule 7, if you're going from an upper, if you're switching the orders from on the top, it would be lower to upper, you have to put a minus. That's what we're going to do. So this is now going to be a -1. And I got to find the integration from 0 to 2. So I don't know what that is. 0 to 2, I don't know. I'll just leave it as it is. And the integration from 2 to 6, do I know? So from 2 to 6, or from 6 to 2 is going to be -1, right? So from 2 to 6 is -1 because we kind of switch the boundaries. If you do go from an upper to lower, you do have to put a minus. If it was from 2 to 6, it would be +1, right? And then from the distance from 0 to 6 is 6. Okay. So go ahead and solve for this. So maybe move this -1 to the right by adding 1. Whoops, I made a mistake. Not 6. Why did I say 6? It should be 4. From 0 to 6 is 4, not 6. And then I'm going to add 1. So, oh, look here. We have a constant or a k. So what you could do is bring it out. And then from 4 plus 1 is 5. And yeah, so it's 5, and then you have to bring down this 3. So it's going to be 3 times 5, which is 15. Okay, so the answer is 15. Okay, let's move on to 3. If the integration from 2 to 6 of f of x d of x equals 20, and the integration from 2 to 6 of g of x of d of x equals -4, find the integration from 2 to 6 of 5 f of x minus 2g of x. Since there's a minus right in the middle, we can write it out as two separate integration, right? So we could say from 2 to 6 of 5 f of x d of x minus the integration of 2g of x of d of x, right? Now, I have a constant in front of the f of x and a constant in front of the g of x. So what can we do with those constants? Put it in front of the integration. Okay, so what is the integration from 2 to 6 of f of x d of x? It is 20, right? And then you have to bring down this 5 minus, when is the integration of g of x? It is -4. And then bring down this 2. Okay, so 5 times 20 is 100. And then it's a minus 8, which gives you 2 minus this becomes a positive. So it's really 108. Okay. Okay, let's do B. So now we got to find the integration from 2 to 6 of 3g of x minus 2 of d of x. So there's a minus right in the middle. So what that means is we can break it into two integrations. So the first integration would be from 2 to 6 of 3g of x minus the integration from 2 to 6 of 2d of x. Okay, this you have a constant here, so you could just take it out and put it in front of the integration. Oh, don't forget you have d of x. Okay, so the integration from 2 to 6 of g of x of d of x is -4. That was given. And then bring down the 3 minus, and then integration, well, what is the integration of 2? It's 2x, right? And then our boundary is from 2 to 6. So we have to apply the fundamental theorem. Basically means upper minus lower. So go ahead and plug in the upper minus the lower. So 2 times 6 is 12 minus 4. And then 12 minus 4 is 8. Okay. And then, okay, so yeah, then you have, remember we were subtracting, so this is going to be 8. So 3 times -4 is -12 minus 8, which is -20. Okay, see, the integration from 2 to 6 of 1 minus x plus 3 f of x of d of x. So what we're going to do is we have a plus, so we can break it into two integrations. So it would be from 2 to 6 of 1 minus x plus integration of 2 to 6 of 3 f of x of d of x. Okay, so let's do this part right here. What is the integration of 1 minus x? You can actually write it into two other integration, or you could just take the integration individually. So what's the integration of 1? X. What is the integration of negative x to the power of 1? Negative 1/2 x squared. Because if you recall how you take the integration of x to the 1, you add 1 to the power and divide it by that power, so that would be 2. And we are going from 2 to 6. And uh, what does it integrate? Well, here we have a 3, so we could take that out. And then what is the integration from 2 to 6? That was given. That was 20. Times it by 3, so that would be 60. So this part right here is 60. And then let's apply the fundamental theorem for this part. So do upper minus lower, so that will be 6 minus 1/2, 6 squared minus bracket 2 minus 1/2, 2 square bracket. That's 6 minus 6 squared is 36, divided by 2, which is 18, minus bracket, and then this is 2 minus 2 squares, 4, divided by 2 is 2. And we know that 2 minus 2 is 0. That's easy. And then what's 6 minus 18? Negative 12. Oh, also don't forget the plus 60, which is 48. Okay, let's move on to 4. Okay, so this time we are given the graph of f of x consisting of 4 line segments and semicircle, right? We have 4 line segments, 1, 2, 3, 4, and then there's half of circle, right? So we got to find the integration from 0 to f of x d of x, 0 to 5, and 0 to 8, and then 0 to 10. So how do we do this when we're given like a table, like given a graph? They don't give us actual values, we have to find it. So let's start with A. What is the integration from 0 to 2 of this graph? This graph is f of x. Well, from 0 to 2, this forms a triangle, right? And what do we know? What do we know about the area of a triangle? The area of a triangle is equal to 1/2 times base times height, right? So the base is 2, and then the height is, I believe it's 2, right? The base is 2, and then the height is 2, and then divide that by 2. Just 4 over 2, just 2. So yes, this will be 2. Okay. What about the integration from 0 to 5? So here's 0, and then here's 5. So you have to find this area and this area, this entire area. But do you see 3 shapes? Yes, I see this triangle, and then actually there's 2 shapes. This could be a trapezoid, this whole thing right here, this trapezoid. So what is the area of a trapezoid? So wait, if you want, you can break it down into 2 integration. So we can go from 0 to 2, which we found already. That's the answer, part A, which is 2, plus the integration from 2 to 5, which is a trapezoid. So from 0 to 2 is 2. And then what's the integration from 2 to 5? So it is a trapezoid. So how do you find the area of a trapezoid? It is which is 1/2 times the height times b1 plus b2, right? So what is the height? The height is uh the height is 2, right? The height is 2. So it's going to be 1/2, and the height is 2 times base 1 plus base 2. So base 1 is, what is base 1? Base 1 is 2, right? This is the base. 2 plus the base 2, which is uh mm, I believe it's going to be 3, right? Yeah, it's going to be 3. Uh, yeah, and that gives you, so 1/2 times 2 is 1, and then 3 plus 2 is 5. So 2 plus 5 is 7. Yeah. Okay. C, what is the integration from 0 to 8 of f of x d of x? So from 0 to 8, uh, okay, so from 0 to 8, it goes from 0 to 2, from 2 to 5, and then 5 to 8, right? Okay, okay, from 0 to 8, right? Um, so wait, how can we set this up? So we know that from 0 to 2, it is 2. And from 0 to 5, we said that was 7. Here, let me write it out. Okay, so from 0 to 8, it would be from, I guess you could, it would be from 0 to 2 of f of x d of x plus from integration from 2 to 5. Actually, no. I've got a better idea. We could take the answer from B because that's from 0 to 5. I just realized that from 0 to 5. So on C, it would be 0 to 5 of f of x d of x plus the integration from 5 to 8. Yes, that would work. Of f of x d of x. And then we know the integration from 0 to 5 is the answer from the previous answer, which is 7. We could just say 7. And then what is the integration from 5 to 8? So this is what? 5 to 8. This is also a triangle, right? That is a triangle. So that would be, mhm, yeah, so that is the area of a triangle. So that would be, the area of a triangle is base times height all over 2. So the area of a triangle is base times height all over 2. The base is, what is the base? The base is this distance. So what's the distance from 5 to 8? 3, right? The base is 3. And then the height is not negative 3, not positive 3, but negative 3 because we're going downwards, right? This point here is 6 comma negative 3, so the height has to be negative 3. Oh, right. So yeah, so it's going to be the base is 3, the height is negative 3 all over 2, and that would be negative 9 over 2. And then just add them up. 7 plus negative 9 over 2, divide this by 1, and then add the fraction, so that would be 14. 14 and negative 9 is 5 over 2. Okay, so that's letter C. Let's move on to letter D. So the integration from 0 to 10. So that's the whole thing. The only difference now we have to find the area of this, which is half a circle, right? It's a half a circle. Well, I know the area of a circle is pi r squared. So half of a circle, we'll just divide that by 2. So what we could do is break it into two integration. We can start from 0 to 8, which is our previous answer, and then from 8 to 10. Okay. So that would be, we could break this into two separate integration from 0 to 8 of f of x d of x, plus the integration from 8 to 10 of f of x d of x. So from 0 to 8, it's the previous answer, which is 5 halves. And then from 8 to 10, we're going to have to uh, do the area of a half a circle, which is pi r squared over 2. So my radius is, what is my radius? So my radius is, so from 8 to 10, that's 2, right? That would be your diameter. From 8 to 10, that would be 2. So the radius is half of that, which is 1. My radius is 1. And then we got to square it. So it's going to be pi 1 squared over 2. So that's going to be 5 halves. And then plus 1 square is 1 times it by pi. So that's pi over 2. And you can just leave it like that. Or you can also say 5 plus pi all over 2. Okay, let's move on to 5. So number 5 says evaluate, for 5, evaluate A to C. So what is the integration from 0 to 4 of absolute value of x, of d of x? So what does the absolute value looks like? It makes that V shape. It would look something like this. Okay, so from 0, we're only caring about from boundaries from 0 to 4. And what is this shape now? It is a triangle. So what is the area of a triangle? It is base times height all over 2. So my base is 4. And what's my height? Uh, so the height is f of 4, which is the absolute value of 4, which is 4, right? All over 2, which is 16 over 2, which is 8. Okay, so the integration from 0 to 4 of absolute value of x is 8. Okay, what about B? What is the integration from negative 2 to 4 of the absolute value of x? So just like we know that absolute value is makes that V shape. The only difference is we're going from -2. Okay, so we're going from -2 to 4, and these are all triangles, right? And how do you find the area of a triangle? Area of a triangle is base times height over 2. So let's look at this triangle here, 1, triangle 2. So the base is -2. And what is the height? All you got to do is plug in negative. This is your height right here. And you can just, I think it's 2. It is 2 because if you plug in f of -2, of the absolute value of -2, which is +2, all over 2, plus the area from uh, 0 to 4. So this part here, what's the base? 4. What's the height? I believe it's going to be absolute value 4, which is 4, all over 2. So -2 times 2 is -4 over 2, and then 4 times 4 is 16 over 2, which is -2, and then 16 divided by 2 is 8, which is hmm, wait, did I get this right? Oh, uh, oh yeah, I made a see. My mistake was if we're going to break it down into two integration, it should have been from -2 to 0 of absolute value of x dx plus the integration from 0 to 4 from the absolute value of x of d of x. Okay, now much better. So what is it? This one is let's see. The base is now from -2 to 0. The base is +2. So that's why I made a mistake. This should be +2, and then the height is absolute value of 2, which is 2, all over 2. So that should be +4 over 2. And then from 0 to 4, the base is 4, and the height is 4. Because if you plug in absolute value, 4 is 4, and then all over 2, and then that gives you 10. Okay. Let's move on to C. So what is the integration from -2 to 7 of the absolute value of x minus 1 of d of x? So you kind of know what that looks like. It's an absolute value graph that is shifted 1 unit to the right. You have a horizontal shift of 1 unit to the right. So that would look something like this. Right? So we have to go from -2 to 7. So let's pretend this is -2, and we stop at 7. So let's pretend this is 7. So how will we do this? Okay, so we have two triangles, right? Triangle 1, triangle 2. So the area of a triangle is base times height over 2. So what's the base of this? It would be, what's the distance from -2 to 1? I believe that's 3. And what is the height? So the height would be this height right here. So you would just plug in f of -2 into your function. So that's going to be absolute value of -2 minus 1. And then that's going to be the absolute value of -3. And then that's the absolute value of -3, which is +3, all over 2. Plus the integration from 1 to 7. Uh, that would be, the base would be, what's the distance from 1 to 7? It would be 6. And then the height would be f of 7, which is the absolute value of 7 minus 1, which is absolute value of 6, which is 6, all over 2. 3 times 3 is 9 over 2. 6 times 6 is 36 over 2, which is 45 over 2. And that is your area. Okay, so right now we have done fundamental theorem calculus number 1. So yeah, fundamental theorem calculus number 1, FDC number 1. Um, if f prime of x equals f of x on a closed interval from a to b where f of x is a continuous function, then this is your fundamental theorem calculus. Remember, integration is like going backwards. Integration is the antiderivative, so you can just go backwards. And then you just apply the upper minus lower. So let's do a few more examples doing fundamental theorem of calculus number 1. So example 6, find the integration from 0 to 1 of this, x minus square root of x all over 2. And how can I rewrite this? So I can rewrite this as from 0 to 1, and then you have this 1/2, and then you have x minus square root of x d of x. And then this 1/2 is a constant, so you could take that out. And then this is x minus square root of x of d of x. Then what I'm going to do is take the integration of each part. So what's the integration of x? It is 1/2 x squared, right? Minus, what is the integration square root of x? Well, I know that square root of x is the same thing as x to the 1/2. So the integration of that is old power plus 1, so 1/2 plus 1, or 2 over 2, all over that power, which is 3/2. So that's going to be 1/2 plus 2 over 2 is 3/2, divided by 3 over 2. When that happens. And then just cross multiply, so that's 2x to the 3/2 over 3. Okay, so this is going to be -2/3 x to the 3/2. And we're going to go from, now we're going to apply fundamental theorem. And then don't forget, we also took out this 1/2. We'll just bring that 1/2 later when we do, after we apply the fundamental. So according to fundamental, you do upper minus lower. That's going to be 1/2, 1 squared, minus 2/3 times 1 raised to 3/2 minus bracket, and then do the lower. So this would be 1/2 times 0 square minus 2/3 times 0 to the 3/2. And believe it or not, this is easy, right? 1/2 square, anything times 0 is 0. And then all we got to do is clean up this part. 1 square times 1/2 is 1/2 minus 1 raised to 3/2 is just 1 times by -2/3. -2/3. What's 1/2 minus 2/3 is -1/3. Oh, no, it's not. You're subtracting, so you need an LCD, which is 6. So you're going to multiply this by 2 and multiply this by 3. That is going to be 3 minus 4 over 6, which is 3 minus 4 is negative 1/6. And then you got to times it. Remember, we took out this 1/2, so multiply this by 1/2. That is negative 1/12. Okay. And that's my final answer. Okay, let's move on to 7. With 7, we have to take the integration from 0 to pi over 6 of 1 minus sine squared theta all over cosine squared theta of d theta. So this is where we need to use one of our identities, and I'm going to use, this is very familiar to, and it's related to our Pythagorean identity. So if you recall, you can use sine squared theta plus cosine squared theta equals 1, right? And if I subtract sine squared theta from both sides, that gives you cosine squared theta equals to 1 minus sine squared theta. So what you could do is replace this 1 minus sine squared theta with cosine squared theta. So this would be cosine squared theta over cosine squared theta d theta. So that becomes 1. And what's the integration of 1? It is theta. Why theta is because we're taking it in respect to d theta. And then just apply your fundamental theorem. So that's going to be pi over 6 minus 0, which is now just pi over 6. Okay, let's do example 8. What's the integration from 1 to 2 of 2 raised to the x minus 1 over x d of x? Well, we could break it down to 2 separate integration, or you could just do it one at a time. So what's the integration of 2 raised to the x? That would be 2 raised to the x over, this is your b value, so b times ln of b. So my b value is 1, right? It's the coefficient of x, so that's 1 times ln of b, which is 2, minus, what's the integration of 1 over x? It is the ln of absolute value of x. And we are going from 1 to 2. So apply upper minus lower. So this is going to be 2 square ln of 2 minus ln of absolute value 2 minus, and then do the lower. 2 to the 1 of ln of 2 minus ln of absolute value 1. So that is, let's see, ln of 1 is 0, so that's going to be 2 ln of 2 and then 2 squared is 4 over ln of 2 minus ln of 2, because the absolute value of 2 is 2, right? So I get, oh, and then distribute this minus this. This is going to be like minus 2 ln of 2. And then you can combine like terms for ln of 2. 4 over ln of 2 minus 2 over ln of 2 is 2 ln of 2 minus ln of 2, which is about approximately 2.192. So you can use exact value, or you can use decimal. Example 9. What is the integration from pi over 4 to x of secant squared t of dt? Well, then secant square of t is the same thing as tan of t, right? So this is your identity. Yeah. So this just becomes tan of t. I think it's one of your Pythagorean identities. And we're going from, and then just apply fundamentals, so lower to upper. So do upper minus lower, so tan of x minus tan of pi over 4. And tan of x is just tan of x minus tan of pi over 4 is 1. Okay, so that was FTC number 1. Now let's talk about FTC number 2. So fundamental theorem of calculus, FTC number 1 is what we just done. You apply the upper minus the lower. And then FTC number 2 is this one. Yeah, so when would I use this? You would use this to find f prime of x. If it just seems more confusing, I would just do FTC number 2. And it's basically uh, f of h of x times h prime of x, which is the derivative of your upper limit, minus f of parentheses g of x times g prime of x, which is the derivative of your lower limit, right? So yeah, go ahead and copy that down. Okay, so let's do example. So it says use the second fundamental theorem calculus to find f prime of x. So number 10, we have d over d of x of lower boundary x and then upper boundary 3x plus 2 of ft minus 1 of dt. Well, what do we know? We know that integrals and derivatives are opposites, so they cancel. So yeah, so this disappears. And or the integration disappears. So now you're left with the d over d of x of the integration. So what's the integration of 5t? It is 5t squared over 2. And then what's the integration of -1? It's just negative t. And we are going from x to 3x plus 2. And then do not take the derivative yet. Instead, just apply the fundamental theorem. So I'm showing you two ways. Fundamental theorem part 1 and fundamental theorem part 2, because you'll see that fundamental theorem part 2 is actually easier. I'm going to show you both ways. So I'm doing, this is FDC number 1. So apply upper minus lower. So this is going to be 5 of 3x plus 2 square all over 2 minus upper. So that would be 3x plus 2 minus, and then apply the lower. So this would be 5/2 x squared minus x. And so clean this up. So this, if I FOIL this minus, this would be negative 3x minus 2. And if I distribute this minus, this would be negative 5/2 x squared plus x. And then you have this 5/2 of 3x plus 2 squared. Then I believe you just take the derivative of each term, right? Because we still have to take the derivative d over dx. So what's the derivative of 5/2 parentheses 3x plus 2 squared? You apply the power rule and the chain rule. So apply the power rule. What's 2 times 5/2? The 2's disappear, so you're left with 5. And then the parentheses stays the same. And then the power is going to be old minus 1. So 2 minus 1 is 1. And then you take the derivative of the inner of the parentheses. So derivative of 3x is 3. And what's the derivative of negative 3x plus 2? It's just negative 3x. And the derivative of negative 2 is 0. What's the derivative of negative 5 half x squared? That would be negative 5x to the power 1. And what's the derivative of x? 1. So go ahead and follow this out. 5 times 3 is 15. And then you have 3x plus 2 minus 3 minus 5x plus 1. So this would be 5 times 3 is so this would be 15 times 3x is 45x. 15 times 2 is what's 15 times 2? I think it's 27 or 30. Mm. Oh, yeah. What? Yeah, 30. And then I was just checking my work. And then where was I? Oh, just collect that because I already took the derivative of these terms. So it's just collecting like term. Negative 3 plus 1 is negative 2 minus 5x. And all you got to do is collect like terms. 45x minus 5x is 40x. And then 30 plus negative 2 is 28. You get 40x plus 28. Okay, the next one. So, oh, no, not the next one. I got to show you I'm going to show you the part 2. Okay, so I'm going to put, that was FTC number 1. Now let's do FTC number 2. Okay, so what we have to do is figure out what's our upper and our lower. So my upper is your h of x. So my upper is 3x plus 2. And my lower is g of x equals x. And then my h prime is the derivative of 3x plus 2 is 3. And then g prime of x is 1. So it's going to be, so it's going to be 5. And then you're going to replace t with your h of x, right? You're going to replace, so it's 5, replace t with h of x, which is 3x plus 2, minus 1, times the derivative of h prime of x, which is 3. Okay, so all I did was I did 5 and then I replaced t with h of x and then times it by h prime of x. Then it's going to be minus parentheses and it's going to be 5 and then this time we're going to replace your t with g of x, which is x minus 1 times the derivative of g prime of x, which is positive 1. Okay, and kind of clean this up. So 4 out is 5, so that's 15x. And then 5 times 2 is 10, minus 1 times it by 3. So that's going to be 3, and then this is going to be 15x. 10 minus 1 is 9. minus, this would be 5x minus 1. 5x minus 1 times 1, that's just 5x minus 1. And then you have this 1 here, so that's -1. So that's going to be 3 times 15x is 45x. 3 times 9 is 27. And then FOIL out this -1, that's -5x plus 1. And that gives you 40x plus 28. Okay. Okay, number 11. So same idea, we have to do find f prime of x. So I'm going to apply fundamental theorem part 2. So it's going to be, you're going to set up as d over d of x of 1 to x. And I don't know, maybe I'll rewrite this as t squared minus 5t plus the cube root of t is the same thing as t to the 1/3 of dt. So what's your upper and your lower? So my lower is 1, so my g of x is 1. And my g prime of x is going to be 0. And then my h of x is x. And then my h prime of x is 1. Okay. What do I do? Okay, so how do we do fundamental part 2? You're going to replace t with h of x, right? So it's going to be wherever you see t, plug in your h of x. So that's going to be 5. I mean, why did I say 5? X squared minus 5 times x plus x to the 1/3 times it by h prime of x, which is just 1. Not too bad, right? Minus, and then this time you're going to replace your t with g of x. So that would be 1 squared minus 5 times 1 plus 1 raised to the 1/3 times it by your g prime of x, which is 0. Okay, this is not too bad because what's 0? This part here is not too bad because 0 times anything is 0. And just clean this up. So this is x squared minus 5x plus x to the 1/3. If you want, you can just rewrite it as the cube root of x. I thought it would be easier, but it doesn't matter. And then times it by 1 is just itself. So here's your answer. Okay, 2 more. So let's look at question 12. Yeah, so we got to find f prime of x. So what we can do is first figure out our g of x and my h of x. So my g of x is the lower, which is -x. And then my g prime of x is -1. And then my h of x is the upper, which is x squared. And then my h prime of x is 2x. So you're going to do is you're going to apply t with h of x, right? So it's going to be x squared minus 1 over t, which is, you replace it with h of x, that would be x squared, times it by the derivative of h prime of x, which is 2 of x, minus bracket, and then you do, you replace t with g of x, right? So this would be negative x squared minus 1 over negative x times it by g prime of x, which is -1. Okay. Okay, clean this up a bit. So x squared is x squared minus 1 over x squared, and then we have to times it by 2x. So this would be, uh, whoops, what mistake did I do? This is x squared raised to the second power, right? Because h of x is x squared, and we have to square that. So this is actually going to be x4. So if I follow this 2x5, 2x, this would be 2x5 minus, what's 2x times 1 over x squared? You can just write it out. 2x over 1 over x squared. 1 minus 2 is -1, so that's going to be -2 over x. And then over here, this would be negative times a negative is a positive, so that's x squared. A negative times a negative. Wait, oh, you have a negative here and a negative there, so that becomes positive. And then you have this extra minus, so it's actually -1 over x. And is there anything you can collect? Yes, this -2 over x and this -1 over x. Wait, I made a mistake. What I did with this, oh, and I didn't multiply this by -1. That's why. So that's a bit off. So -1 times, well, I know that negative x squared is positive x squared, and then you have a negative because of this minus, right? So that'd be negative x squared. Then you have this, then you have to distribute this minus. Over here, a negative over a negative is positive, and then you have this extra minus, so that's -1 over x. Then you would distribute this minus, so negative times a negative is positive. Negative times a negative is positive. This should be +1 over x. Much better. And when you clean it up, this is going to be 2x5 plus x squared, and then -2 over x plus 1 over x is -1 over x. There's your final answer. Okay, 13. 13 says find f prime of pi over 6 if f of x equals to the integration from this 2 of sin of x as square root of 8t of dt. So what you're going to do is step 1 is find, use FTC. Number 2. That's the first step. So this would be d over d of x of the integration of 2 of sin of x square root of 8t dt. And what do I know? So my g of x is my lower, so that's 2. G prime of x is 0. My h of x is sin of x. And then my h prime of x is, what's it of sine of x? Cosine of x, right? Okay, then what I would do is plug in t for h of x. So this would be square root of 8 and replace t with h of x, which is sine of x, times the derivative of h prime of x, which is cosine of x. I'll put the cosine of x in front of here. Minus, right? Minus, then you apply 2 for, you're going to apply t for 2 or g of x. So this is going to be square root of 8 and replace t with g of x, which is 2, times g prime of x, which is 0. Okay, so you get cosine of x square root of 8 sin of x. And then this is easy, right? 0 times anything is 0, and then minus 0 is just 0, right? So my f prime of x is this thing, cosine of x square root of 8 sin of x. And then step two, I would plug in my x value pi over 6. So they want to find f prime of pi over 6. So given what they want, f prime of pi over 6. Where we see next, plug in pi over 6. Okay, so what is the cosine of pi over 6? It is positive radical 3 over 2. And then this is going to be, uh, so what is pi over 6? Pi 6, pi 4, pi 4. Pi 6 is like your 30 degrees. So it has an x coordinate of radical 3 over 2 and a y coordinate of 1/2, right? So the sine of pi over 6 is 1/2. 8 times 1/2 is 4, and that is square root of 4 is 2. And finally, you know that the 2's cancel, so you're left with square root of 3. And that is your final answer. Don't you agree that the fundamental theorem part 2 is much easier than FTC number 1? I agree. Okay, so that's basically a fundamental theorem. There's a part 1, part 2. You decide which one you prefer. I'm going to stop here.